Alright, try it. Graph the parabola for the given point P. Use symmetry to find the coordinates of another point on the parabola. So we're going to look at problem C on the try it. The function is x squared minus 6x plus 5. And the point on the parabola that we want to find, use to find another point would be the point containing the coordinates 4, negative 3. So first of all, let's go ahead and graph the parabola. So if I let x be 0, so we'll start picking points. If I let x be 0, I'm going to plug this into the expression x squared minus 6x plus 5. These both go to 0, and you're left with 5. So my first point is 0, 5. 0, 5. So there's my first point right there. Okay? If I let x be 1, so if I plug 1 in, minus 6 times 1 plus 5, that's 1 squared, minus 6. 1 minus 6 is negative 5. Negative 5 plus 5 is 0. So at 1, I have, when x is 1, y is 0. So when x is 1, y is 0. So there's a point right there. Let's go to negative 1. So if I plug negative 1 into the expression, minus 6 times negative 1 plus 5. This turns into positive 1. Negative 6 times a negative 1 is a positive 6. And this is a 5. So it looks like we have 12. Okay. Alright, looks like that's going up further. So this is negative 112. So that's way up here. Okay. Let's go the other direction. Let's go to 2. So we'll erase this real quick. And now let's go to 2. So when x is 2, so here I've got 2 squared minus 6 times 2 plus 5. Well, that's 4. That's minus 12. That's plus 5. 4 minus 12 is negative 8. Negative 8 plus 5 is negative 8 plus 5 is negative 3. That's negative 3. Negative 3. Okay. Alright, so we have negative 3. So when 2, x is 2, that's negative 3. So plot a point right here. Alright, let's keep going. So what happens when x is 3? So we go 3 squared minus 6 times 3 plus 5. So that's 9 minus 18 plus 5. So 9 minus 18 is negative 9 plus 5 is negative 4. So we have negative, so 3 negative 4 is right here. Let's keep going. Let's do some more. Okay, so let's try 4. So here I have 4 squared minus 6 times 4 plus 5. That's 16 minus 24 plus 5. 16 minus 24. 16 minus 24 is negative 8. Negative 8 plus 5 gives me, negative 3. So it looks like we turned right here. So it looks like this is the vertex right here. Let's take one more point. Let's go 5. Let's go one more. So we'll go 5. So when I plug this in, I have 5 squared minus 6 times 5 plus 5. This is 25 minus 30 plus 5. 25 minus 30 is negative 5 plus 5. That winds up giving me 0. So we're back to here. So I now have a picture of my parabola. We're going to put this in a different color. Let's pick something. It's very easy to see. We're going to go right here. Alright, so there is approximately my parabola. If I pick my line of symmetry, which we'll put in red, you know it's going to be crossing, it's going to be a vertical line, and it's going to go right through the vertex. So there's my line of symmetry. There's my line of symmetry. And now, let's see, they said my point was 4, negative 3. So here's 4, negative 3, right here. Okay? I look at the distance of that. Looks like I'm 1 unit away, so I'm going to go exactly 1 unit away on the other side. Notice that creates a 90-degree angle right there. So this would be my other reflection point, and that's also on the line. So let's see, this is a distance. My vertex, by the way, my vertex was 3 comma negative 4. Okay, so this was 4. So now this is going to be 2, so this is 1 less. So my reflection point now is going to be 2, negative 3. 2, negative 3 would be the other point on that line given the reflection, given the initial point. Okay? So that's how you find a reflection point. So you create your parabola, graph your parabola, pick a point, find the point that's exactly the same height, vertical height as the reflection point, as the original point, and then you can find the x-coordinate looking at it'll be the same distance from the line of symmetry as the original point. So that would be so that's how you do it.